Welcome to the Basic Mechanical Engineering playlist. Today I will explain thermodynamic systems. So basically there are three types of the thermodynamic system: open system, closed system and isolated system. So today we will discuss about these three basic different types of the thermodynamic system briefly. Listen it carefully so that you can understand it exactly. And I am damn sure there will be no any doubt in your mind. So let's see first of all the definition of thermodynamic system. Thermodynamic system is defined as a certain quantity of matter or region in space under consideration of analysis. So very simple, it is a certain quantity of matter or you can say region in space which is under consideration of analysis. Or in short you can say a quantity of matter or a region in space chosen for study. So say for example, if this is the region in the space for the analysis, so you can say this is the system. The region outside the system is called surroundings. So this is the system and the region outside of this system is called as surroundings. So I can write over here, this portion is the surroundings. So look at this figure. If we focus over here, this space between the piston and cylinder, so this is called as system, and outside of this system is called as surrounding. Now next, the real or imaginary surface that separates the system from its surroundings is called boundary. So very simple, the real or imaginary surface that separates the system from its surrounding is called as boundary. So this one is the boundary. So let me write over here, this is the boundary. Next, a system and its surroundings. Look at this figure, system and its surroundings together is known as universe. So mathematically you can say universe is equal to system plus surrounding. So whole together considered as a universe. A system can involve fixed, moving, real and imaginary boundaries. So boundaries can be any of these type. Here you can see this is the real boundary and particularly the end of the piston is called as the movable boundary, whereas the surface of this cylinder is called as the fixed boundary. If we consider this region between the piston and cylinder as a system. Look at the power plant. If we focus this portion for our analysis, then it is called as system. Here the boundary of the system is imaginary. Basically, systems are classified as open system, closed system and isolated system. So let's see briefly one by one all these three types of the system. So here, look at this figure. This is the example of the open system and here you can say this is also the open system. So very simple, in symbolic notation you can understand in the open system heat as well as the matter or you can say mass can be transferred from the system to surrounding or vice versa from the surrounding to system. And here in this figure you can say the heat is transferred from the system to surroundings and mass is also transferred from the system to surrounding. That is called as the open system. So very simple, briefly you can say in case of open system, mass is transferred as well as energy is transferred. So in open system, both mass and energy are transferred across boundary. So as we have discussed, in case of open system, mass as well as energy can transfer from the system to surroundings or from the surrounding to system. Examples: gas turbine, IC engines, etc. Now if you look at the figure of the open system, so you can draw the turbine And here this is the input of the turbine and this one is the output of the turbine for the steam. And here this shaft is the output shaft of the turbine where you can take the work done. And if you consider this is as a boundary, then this one is the system and outside of this system is called as surrounding. Here this boundary is the imaginary boundary. So I can write over here, inside of this boundary is the system, and here you can see heat and mass both are transferred from the surrounding to system. Here you know that steam is generally entered into the turbine, and so that you can say the mass is transferred, and the steam having certain amount of the heat, so we can say heat is also transferred. So in open system, mass as well as energy both are transferred. Similarly, at this end also steam as well as with certain amount of the heat is also exit from the turbine to the surrounding. And here you can take the useful work from the turbine. This is also another example of the open system. Here it is written, for example, boiling water without a lid. Here you can see, or you can say without a cap or cover. So here in this case, heat escaping into the air, so we can say the energy is transferred. Next, in the same case, steam, which is actually the mass escaping into the air, so mass is also transferred. So this is the example of the open system. Now next, second one, closed system. So in this figure you can see this one is the example of the closed system. This is the figure for the representation of closed system. Here you can see only the heat is transferred from the system to surrounding and vice versa. So we can say in case of closed system, mass is not transferred, only energy can transfer. So in closed system, only energy is transferred across the boundary. Examples, piston cylinder arrangement as shown in figure. So I am going to draw over here the piston cylinder arrangement. So this is the cylinder, and in this you can see the movable piston which will reciprocate inside the cylinder, and this portion that is filled with gas, and that is known as system. So if we supply a certain amount of the heat with the help of the burner to the system, then heat is transferred. That means we can say energy is transferred from the surrounding to system, and due to that it will expand. But due to the expansion of the system, mass is not transferred, only the heat is transferred from the surrounding to system. That means energy is only transferred, mass is not transferred in this case, and so that it is called as closed system. And so that you can get the useful work done at the piston end. Example of a closed system, that is the pressure cooker. It allows heat to be transferred from the stove to the water. Here you can see heat is also transferred to the surroundings from this surface, but steam is not allowed to escape. That means mass is not transferred due to the gap. So here also you can see mass is not transferred. That's why it is considered as an example of closed system. Now third one, isolated system. So here you can see isolated system. So in case of isolated system, you can say mass is not transferred as well as energy is not transferred. So in simply we can say neither mass nor energy can be transferred across the boundary in the isolated system. So the example of the isolated system is perfectly insulated thermos flask. So in an isolated system, neither mass transfer nor energy transfer takes place across the boundary. It is a system of fixed mass and no work or heat energy crosses its boundary. That's why I have written over here in the symbolic notation for the isolated system. Examples: perfectly insulated thermos flask. It is actually not possible because of always there is some amount of the heat loss from the system to surrounding or from the surrounding to system if there is a temperature difference. But you can assume if it will take very long time, then you can say it is a perfectly insulated thermos flask. So we can say it is only imaginary system. But for simplicity in analysis, sometimes it is considered. Now the summary of the types of system. So here you can see first one is the open system where heat is transferred as well as mass is transferred. And so that it is called as open system. Here you can see in this figure. Second one, closed system. Heat transfer is possible but no mass transfer. So here in the symbolic notation you can say due to the cap mass cannot be transferred. Only heat can transfer from this surface. And in case of the isolated system, no heat transfer as well as no mass transfer. So put your valuable feedback in the comment box for motivating me to make more videos. Thanks my dear friends for watching this.